Okay, so let's start our class. So, what we were discussing in the previous class is about grammars. So, today we'll see how we can categorize different grammars. Okay. So, for that, we have to see the Chomsky classification of languages, this one. Chomsky classification of languages. So, basically, Chomsky has given the formal definition for this, and based on the grammars, the structure of the grammar, and the constraint which we can put on the grammar, we can categorize the languages. Okay. So here we see my voice. Reply in the chat box. Reply in the chat box. My voice is audible or not?
Yes, sir.
Okay. So we know the definition of the grammar over here. No, we have seen the definition. According to that, a grammar is Vn summation p comma s. Okay, where what is Vn? Vn is set of variables, summation is set of terminals. So this we have seen earlier. S belongs to Vn, so start symbol S is one of the variable. So we want to classify grammars. We have to do it only by considering the form of productions. Okay, so the main how we are going to classify will be based on what kind of production we are choosing in our grammar. So Chomsky classified the grammars into 4 types. Okay. So what we are calling it as, we are calling it as type 0. 4 types are there. So basically we're having type 0, then type 1, type 0, type 1, type 2, type 3. Okay, so these are the 4 types of grammars. Okay, so let us see one by one these. So type 0 grammar is any phase structure grammar without any restrictions. So here what we are saying is that all the grammars so which we have considered are types. So basically everything. So the most general form of the grammar. Okay, so where we don't apply any kind of restriction is your type 0. Okay, so we'll see few examples, then it will be clear. So here we are having one definition. So to define the other types of grammar, we need a definition. So this is the definition which is we have to consider. So in a production of the form xi a phi, okay, phi a xi implies phi alpha xi. Okay, so where a is a variable, we know, we can see, and phi is called the left context and xi is the right context. Okay, and phi alpha xi is the replacement string. So this form we have to keep in mind while we are observing the productions. Okay, so here this is the left context, xi is the right context, and this entire thing is the replacement string. Okay, this replacement string. So few examples have been given. Let's see. So in AB, small ab, capital A, B, C, D implies AB, A, B, B, C, D. Okay. So in this AB is the left context and this BCD is the right context. Okay. We have to identify where we are having the what variable, and based on that we can say that what is left context and what is right context. Okay. This is left, this is right. This entire thing will be called as a replacement string. And alpha, what is alpha? If you want to identify, so whatever comes in place of your variable a is the alpha basically. Okay, so a is replaced by ab, that is your alpha. Okay, so likewise in a c tends to a is the left context. We are saying this one, and nothing is there means empty is the right context. Okay, and yeah, alpha is equal to empty. Okay, so basically what is happening over here, c is getting erased. Okay, the production simply erases c when the left context is a and the right context is empty. Okay, so here the only left context survives. So in this case, if you see for c implies empty, so here left context is empty, right context is empty, c is getting erased. Okay, so alpha is equal to empty. So simply erases c in any context. So these are few examples, and you can see many more examples so that you can recognize what is left context, what is right context, what is the replacement string, what is alpha. Okay, so all that. So production without any restriction is called a type 0 production. Okay, so here everything is allowed, like we are able to erase the c itself. Okay, the variable itself. Okay, and do such manipulations. So production of the form phi a xi implies phi alpha xi is called type 1 if alpha is not equal to empty. Okay, so here what we are doing, considering the general form of the production, we are applying a constraint and we are saying that alpha cannot be equal to empty. Means what? We are saying that the variable cannot be erased in the type 1 production. Okay, so firstly we are saying about type 0 production. Okay, and then we are saying about we are applying restriction, then we are saying about type 1 production. So in type 1 production, alpha cannot be equal to empty. So we'll see the definition for this and it will be easier for us. So here this is we are having the definition for type 1, I think. Okay, here. So a grammar is called type 1. The other name of type 1 is context sensitive or context dependent. Okay, if all the production are of the type 1 production. Okay, so the production as implies empty is also allowed in type 1 grammar. But in this case, S does not appear on the right hand side of any production. So this is an exception. Okay, so previously what we have said, the variable cannot be erased, but here we are allowing the start symbol S to get erased. Okay, and along with that, we are saying that the S should not appear on the right hand side of any production. If we have this production, then S cannot appear on the right hand side. Then only it will be called as type 1. So basically, this is nothing but a kind of giving a name to the structure of the grammar and saying that if this kind of production we have in our set of production, then it is of this type. Okay, whether it is type 0 or type 1 or whatever. Okay, so here that we are saying. So this name you have to remember because it is not necessary that it will be it will be called always type 1. Okay, it can be called as context sensitive also, it can be also called as context dependent also. So these are the different names which we are giving to the same thing. Okay, so that is your type 1. Let's see one by one definition and then we'll try to see few examples. The language generated by type 1 grammar is called a type 1 or context sensitive language. Okay, so here basically when you know the grammar, then you can say something about the language generated with the grammar. Okay, so this is that. Okay, so the language, if the grammar is of type 1, then the language is called as context sensitive language. Okay, that's what we're saying. Okay, let us see. This is a note, we'll see it later. Let us first cover the definitions. A type 2 production is a form of production where you have this form A implies alpha, where A belongs to a variable. Okay, so this is basically what we are saying is a variable. Okay, and alpha can be combination of variable and terminal. Okay, So alpha can be combination of variable and terminal. So on the left hand side of the production, we must have a variable, and on the right hand side of the production, we can have a combination of variable and terminal. Okay, so in other words, HS has no left context or right context, so it has to be single variable. And these are the few examples. S implies A implies A. So on the left hand side, you can see that there is no left context or right context. There is only one variable. On the right hand side, here you can see you are having A, that is combination of variable and terminal. Here only terminal, and here all are terminal. Okay, so even if you can have empty also, because this is asterisk, so empty will be part of the setup. R type 2 production. Okay, so these are few. So what so we have seen type 0, that we are saying free of constraint. Type 1, the variable cannot be erased. Type 2 is of this form. It implies alpha. Okay, so if we have this form, then it is type 2, where A is variable and alpha can be Vn union summation of elastic. Okay. And follow-up definition after type 2 is your language. And the grammar is called type 2 grammar. If it contains type 2 production, it is also called as context free grammar. Okay, so this is the name which we are giving to type 2. We are calling it as context free grammar. So a language generated by context free grammar is called type 2 language or context free language. Okay, so this is the follow-up, that is grammar is called as context free grammar and the language is called as context free language. Okay, so these are the two terms which you have to take away from this: context free grammar, and the language generated by that is called as context free language. Okay, this is type 2. Now last one, a production of the form A implies A, small a, or A implies AB. Okay, so this is the production which we are including in our type 3. So basically what constraint we are applying. Okay, so here we are saying that we can only have a single variable. On the right hand side we must have a single terminal. Okay, so this is the one which we can allow, and the other one is A implies AB. Okay, so this is another one where A, B definitely are what they are variable. A is your terminal, so this is called as type 3 production. So if you can have these two sort of productions type in your set, and it can be called as type 3 production. Okay, so one is this one, another one is this one. Okay, so a grammar is called type 3 or regular if all its production are type 3. A production S tends to empty is allowed in the type 3 grammar. So here we are saying that apart from these, we can allow S tends to empty. This is an exception, but in that case does not appear on the right hand side of any production. Okay, so this is the constraint which we are applying. So these things you have to keep in mind while you are designing your setup production grammar. Okay, so yeah, so let me see if we have anything. Okay, so you will find so whenever you try to design a grammar, you have to observe what how you are representing the grammar. Okay, and what type you're using, whether it's type 0, type 1, type 2, or type 3. Okay, so in our case, basically when we are because we have studied DFA. Okay, so this is an important, let me give you the block diagram for that. Languages and their relation, here this one. So here, and I see it very closely. So here we are having a relation. So this arrow should go up to here, है ना? ये arrow यहाँ पर रुक गया, यहाँ पे जाना चाहिए. Mistake है यहाँ पे, ठीक है? So here what we are saying, there is a relation between this finite automata. This is nothing but DFA. Okay, you can call it as FA or you can call it as DFA. So there is a relation between regular grammar, or it is also called as type 3 grammar. Okay, so in other words, what we are saying, if we have a DFA for some problem, so ultimately it will be type 3. Okay, or if you have a grammar which is in type 3, then you can model it by DFA. Okay, so this is clear to everyone what I'm saying? Hello. Okay. I don't know what is happening. Okay, so that is the case. So there are many examples which are given. Construct a context-free grammar, generating language. है ना? So basically, these are many examples are given. We'll see few of those. So firstly, you have to realize that uh, designing a grammar, okay, in a it is an art. Okay, nobody can give you the set of rules and say that apply this and you'll get. Okay, because we can have more than one set of grammar that can represent the same language. Okay, that is possible. Okay, and definitely you can learn this by doing practicing more and more questions. That is the only way. Okay, so you can start from that a to the power and b to the power n question, and you can simply expand on that. Okay, how you are choosing the productions and what is happening. Initially, don't worry about the structure of the grammar, but slowly you'll realize that if you want that grammar to be a particular type, then you have to apply the constraint. Okay, so yeah, because otherwise, we cannot categorize those grammars. Okay, so that we have to do. So let us see the examples. And there is some theories there and about. So we'll see this operation. So let me find few good examples that languages and their automata. So here we are saying construct a context-free grammar generating these languages. So what is context-free? What is type 0, type 1 or type 2? So it is not type 0. Definitely we know that. Type 1, if you remember, what is type 1? Alpha cannot be equal to empty. Okay, variable cannot be raised. This is type 1. Okay, where the production is of the form phi a xi implies phi alpha xi. Okay, so this is your type 1, that is your context sensitive. You have to remember this. Okay, what you're talking about. This is type 1. What is type 2? Anybody remembers? What is type 2? A tends to alpha. Where what is A? A is variable. What is alpha? Alpha is combination of Vn union summation holistic. This you have to remember because this is the form which we are considering. Okay, this is your Vn union summation holistic. Okay, and the type 3 just now we have seen. What is type 3? Type 3 is A tends to small a or A tends to is in this form. So here S tends to empty is allowed in type 3. है in that case, S should not appear on the right hand side. Likewise, in this case also, in the type 1 also, okay, we can have S tends to empty, but S should not appear on the right hand side of any production. So if you are targeting, okay, so if you have some problem in saying that design a DFA, then you must be able to write that problem language in terms of this productions. Okay, so
That
yeah,
is VN union summation whole aspect. इसका मतलब
वीएन यूनियन समेशन होलास्टिक का मतलब ये है कि लेट सपोज वीएन इज अ सेट ऑफ वेरिएबल्स। ओके, लेट अस से है ना, वेरिएबल आपने लिया है ए बी समथिंग लाइक दैट, ठीक है। और आपका समेशन जो है दिस इज सेट ऑफ टर्मिनल्स, ओके, ये है ए बी सी समथिंग लाइक दिस। So on the right hand side, you can have any combination of these two, okay, along with empty, ठीक है। आ रहा है समझ में? जैसे पहले हम क्या लेते थे, 0, 1 होल एस्टिक। Okay, so what do you mean by this? We mean by this as a set where empty is included. We can have 0, we can have 1, we can have 1 1, we can have 0 1. Okay, we can have any combination of these two. Okay, this is an infinite set. Likewise here also, वीएन यूनियन समेशन होलास्टिक मींस एनी कॉम्बिनेशन ऑफ दीज टू, है ना। जैसे कि इसमें ए ले लो या ए ही ले लो सिंपली, और एम्प्टी यू कैन टेक। ओके, लाइकवाइज यू कैन टेक एनी कॉम्बिनेशन ऑफ दीज टू, ए सी यू कैन टेक ए बी सी। ओके, सो any combination you can take. Is it clear? हेलो,
यस सर।
ये कौन बोल रहा है? यस, हेलो।
अभिषेक। यस सर।
हाँ, स्पीक इट प्रॉपरली, है ना। So after that, so you can start from here. So this is the one. So let me give you a few examples so that you can start at least. So you might realize that this, okay, so this problem basically, you cannot design a DFA for this. Okay, it is not possible. Even if you can try, but you cannot design it, okay, because the other argument which we can say is that this is not of type 3. Okay, if a grammar is of type 3, then definitely we can have a language that we can call it as regular language, and we can have a model that is your DFA for it. Okay, but this particular language is not regular language. Okay, so we'll see how we can model this. So for this we have a different computation model that we call it as PDA, pushed on automata. Okay, so that we'll discuss later. Okay, that is one of your chapter, pushed on automata. Okay, so we'll see this. uh, so you can begin from here, where you can try to model this particular language. Okay, and you can try to realize how this is done. Okay, so all of has to basically start from s implies. Okay, so we have to keep in mind that we have to generate. So what, so let us take few instances of this. If you keep n is equal to 0, then we'll have language. This is one of the sentence. If n is equal to 1, then we'll have 0 1. So if n is equal to 2, we'll have 00 11. Likewise, if n is equal to 3, then 000 111. Okay, now I think you might got the idea how we're generating the sentences. Okay, so our target is to generate this set, okay, with the help of the grammar. So definitely we must, it is quite, this is thumb of rule that we must have an s, that is start symbol, otherwise we cannot produce the sentences. So you should try it. So the only thing which you have to do is that try to realize what is the general pattern which is occurring. So as you can see, there are equal number of zeros and ones. Okay, so here that can be so done by this 0 as 1. Okay, so it's not necessary that the style of thinking should be same. Okay, so everybody can think, come up with a different idea. It's not necessary that you have to do it this way, but this is one of the way. So 0 s 1. So So what you're doing, you're saying that s can be replaced by 0 s1. Okay, so always whenever you replace s by 0 s1, you'll generate equal number of 0 and 1. Okay, so that is that will happen. And along with that, definitely we have to somehow close this variable s. Close this means we have to replace the variable s in a such a way that we must generate the sentence. Otherwise, if you have only this production, you cannot generate the sentence. So we must include s tends to one terminal we have to pick. So we can, let's pick s tends to empty. Okay, so these two are quite sufficient enough to model this language. Okay, so let us take few examples. So s tends to empty, it is part of the language. Another possibilities, we start from here. S implies 0 s1. Okay, and then we replace this s again by 0 s1. So you definitely you will be able to see that how nicely it is generating equal number of zeros and ones on the both side. Okay, so each time you do that again, there will always be equal number of zeros and ones. Okay, so yeah, this s is replaced by again 0 s1. So 0 s1 1. So this s we are replacing by 0 s1 here. Okay, so in order to get the sentence, at last we have to apply this s tends to empty. So we'll get 000, let's suppose 111. Okay, so this is part of the language. So like that you can generate and do it. Okay, so keeping this in mind that this is a structure which we can consider in order to generate equal number of zeros and ones like this. Okay, so if you keep this in your scope and try to model some other thing. Okay, likewise. So here I don't know what has been used. Okay, so here as you can see, that is used strictly, and so that what we have said is been used. So yeah, so another way of okay saying is that okay, so a compact notation which you can use in order to represent this entire line, which I have suggested in the previous class, that how compactly you can write. So if you want to write it compactly, then you can write something like this. So this entire thing can be represented in a line like this: 0 to the power n s 1 to the power n. Okay, like this you can write by the definition over here. Okay, so this definition can be used. So previously also this definition देखो यहाँ पे लिखा है, this one you can see. ठीक है, so like that. So that is one. Another, यहाँ पे देखो how है ना, this is the language. Okay, so here the question is to find what is the language which is generated by the grammar G. Okay, the set of production is this. So we can, so this is basically kind of proof or a way, I mean, you can say that this is a systematic way of representing thing where है ना, so definitely the way to start to produce a sentence is considering start symbol s. So we have over here only one production है ना, for s, so that we have to consider. And what other options we have after that we have to see. Okay, so if you apply s implies aca, then the only thing which we can do is that we can replace this c, capital C. Okay, so what options we are having? Either we can choose this one, ACA or B. Okay, so if you pick one, then you have to pick another one for the other case. Okay, so here we have picked, let's suppose B. So ये मिल गया अपने को ABA. So ABA is part of the language. Okay, so the alternative was left, so that we can apply here. The application of S implies ACA. So if you apply that production, okay, C tends, this alternative was left, C tends to ACA. So this production we are applying n minus 1 times. So if you apply this n minus 1 times, so ultimately you will get a to the power n, C a to the power n. Okay, because 1a was already there. Okay, 1 plus n minus 1 is nothing but n. है ना? 1 plus n minus 1. So ultimately this to get cancelled and this will remain. So this is a to the power n, a to the power n will remain. And ultimately these two options we have exhausted, but in order to get the sentence we have to replace this s by 0 s1. Okay, so that is the okay, so that is the, I mean, you can say that this is the way to get the sentence. Okay, so if you want to write it compactly, then you have to use this. Okay, so this is the way to get the sentence. Okay, so if you apply s implies aca, then the only thing which we can do is that we can replace this c, capital C. Okay, so that can be write in a compact way. That is, uh, okay. So as you can see, a to the power n b, a to the power n. So if you take n is greater than equal to 1, then ultimately this entire thing can be generated. Okay, if you place n is equal to 1, then you will get a b a. Okay, so that this is suggesting, and after that you can pick any value for n, and then you will get equal number of a's in the both side, and in the middle you'll have a b. Okay, like this. Okay, so like this you can generate this language. And let us see. Okay, okay, so such you have to try to realize what is happening in this. Once you get it, then the same concept you can apply. Okay, let's see few more examples. So this is find L of G. So here this one notation has been used, which you don't know, this plus one. Okay, so this plus a comma b, yeah, whole to the power plus is there. Okay, so what does it mean? It means that excluding empty. So a comma b whole asterisk means all the possible combination of a and b, including empty. But if you remove empty from that set, then it will we can write that in this form: a comma b whole plus. Okay, it means what? Excluding empty. That's what it is. So this is the production which is given to us. So if you see, then what we can generate from this production, definitely we can have. Let's first see the trivial cases where a. So here a belongs to L of G. Okay, S tends to B is also there. So B belongs to L of G. Okay, this is part also part of the language. And the two alternates these are left. So let's apply one by one. S implies you should take AS. Okay. So what options we are having for this S? We are having three alternate options. These three we can apply. Okay. Either you can replace this S by A, or you can replace S by B, or you can replace it by BS. Okay. So one by one, if you see, if you replace this S by A, then you will get AA. Okay, so let us write in the set A, B. This is already there. So if you replace this S by A, then you will get AA. If you replace S by B, then you will get AB. If you replace this S by BS, okay, so B and then AB, anything. Okay, B then anything means you can have A or you can have B, like that. Okay, furthermore, we can repeatedly apply this production and you can generate basically any combination of A and B. But here we cannot generate an empty. Empty is not part of the set. Okay, L of G. This is, so here that's what we are saying is that this entire thing can be represented like this: A comma B comma B plus. Okay, so this is same as this. There's no difference. Okay, both are same. This is only a notation which is used to represent the set like that. Okay, so that is it. So here is a very interesting question. All the palindromes generate all the palindromes over A comma B construct generating L. So if you until unless you know the base conditions, it will be hard for you to generate any such kind of language. So here, as you can see, empty is a palindrome. Okay, AB are palindrome. AB means single A, single B. These are palindromes. Okay, after that, these two patterns are there: AXA and A, sorry, BXB. Okay, so X can be replaced by what? It can be replaced by an A or it can be replaced by an B. Okay, so likewise. So these are the production which is used. यहाँ पे देखो डायरेक्टली ये इनको इंक्लूड कर लिया गया है. ये single terminals are there that are included in the language, and then this pattern has been tried to model AXA and BXB. So that can be easily done by this. S tends to ASA and S tends to BSB. Okay, so each and every time what options we are providing for an S, either it can be replaced by an empty or A or B. Okay, so ultimately the pattern will not be get affected, and each and every time you will get a palindrome. Okay, So if you're designing your grammar in a such a way that you are providing an option that it is not part of the language, let's suppose, then your grammar is not correct. That is the way of verifying whether your grammar is good enough or not. Okay, you might design the grammar which is generating the language, but it might also generate few strings that is not part of the language. Then your grammar will be wrong. Okay, remember this. Okay, so if something like suppose s tends to something is there, let's suppose ab, if you have included something like this, right, then your entire grammar will be wrong. Okay, because this is not part of the language and you're producing something which is not required. Okay, so don't do that. So yeah, so see questions like this and try to make an attempt. यहाँ पे देखो बहुत अच्छा क्वेश्चन दिया है, W से W transpose, so A comma B holistic. So your W can be replaced by any combination of these A B. So if you take simple example A B C and then W transpose will be A. ये ऐसा आपका string include होगा language में. ठीक है, A B and B A, this is reverse basically transpose over here and we are considering string यहाँ पे दिया हुआ production. Okay, try to model this a to the power and b to the power and c to the power I. Okay, this you have already seen how to model, but how to include this. Okay, बिना प्रोडक्शन देखे इसको ट्राई करके देखो. So this, that is the only way. Here I cannot make you practice the problems. Okay, that is the constraint which we are having. So all of you try to design this language. Okay, given the language, design the grammar. Given the grammar, design means try to verify what language we are getting from that. Okay, so many examples are there. You can see the solution and you can try by yourself. देखो यहाँ पे a to the power and b to the power and c to the power and this is extended. ठीक है, so you can see x means this is copy whatever you have. Let's suppose a, then a, b है तो b है. So that how we can generate that. And x is not necessarily it will be a b, it can be any combination. Let's suppose a b है ना, तो a b है तक इसको x मान रहे हो तो क्या आएगा फिर a b like that. Okay, basically you cannot, I think, let me check it. Let us check. Okay, so for this we are having the production. These are the production which are there. You can check whether you are getting the same thing or not. Okay, so for today's class, I think this is sufficient. Try to practice as many questions as possible. Okay, then only you will be, you'll get hold of these things. So any questions, anyone? Hello? Is it clear to you? Today's class, is there any doubt or any questions you can ask? Okay. Okay, I'm sharing you the attendance link. Submit the attendance and then